Welcome to Shelley Physics, brief episode on resolving force vectors. Now, it's coming off the worksheet example that you'll have in class. And there it is, you see it right there. There's a 35 Newton force going up, a 25 Newton force going to the right, and a 20 Newton force going down. Now, what's that mean? This could be like, I don't know, this could be a ball being thrown or something like that. I mean, it's got some weight to it. It's sitting in someone's hand and they're throwing it to the side. Whatever it is, it's got these various forces on it. Well, our job is to try to find out what the acceleration of the object is going to be. And we get that from summing the forces and applying Newton's second law. And so that's what we're going to see here. We're going to have turn that screen off there. All right, so I'm going to recreate that force diagram. 35 newtons up. That is not an N. There we go. 35 newtons. 25 to the right. I'm going to try to make those arrows look similar in size. So 35 is a little bit longer than 25, and then 20 is a little bit shorter than 25. And those force vectors are representing the amounts and the directions. They're all coming off the object. So this is representing a force pushing up. That might be the hand. Okay, this could be like overall person could be like throwing it up at an angle. I think that's what we can think about here, because there has to be more upward force than down if they're going to throw it in any direction upward. But there's also a right hand force, so there's a 25 Newton force to the right. All right, so here we see the ball and all the forces acting on it. Now our job is to try to bring those, kind of simplify those forces down into just a few. And if we can look at this 35 Newton force and the 20 Newton force, you can see that they're opposite of each other. Now, if we're in a tug of war match and I push one way and you're pushing the other, or I guess a tug of war you're pulling, then the overall motion will be the result of those two forces. So if I'm pulling to the right with the same amount of force that you're pulling to the left, the rope's not going to go anywhere. Only if one of us overpowers the other, if there's more force one way than the other, then we're going to start accelerating toward that direction. It's not going to be like if only one person's pulling, because if one of those sides, if you've ever seen tug of war happen, usually the side that sees they're clearly losing, they want to get one last jab in against the winners, and they might all let go of the rope at the same time. That causes the winners to fall over into the mud. Kind of a fun thing. But it's a result of the two forces together. So what we're going to do is we're going to look at summing the forces in the x direction, and we're also going to sum the forces in the y direction. So that word sum, sum, we're adding. And that's just this little Greek letter here. It's a capital sigma. Sigma. It means sum of. It's the sum of. So we read this sum of the forces in the x direction. In the x direction, think like a Cartesian coordinate plane system. You got the x direction and the y direction like that. So if we look at only the x direction forces here, the only forces in the x direction is the 25 Newton force. There's nothing to the left. There's only a force to the right. So the sum of the forces in the x direction is just 25 newtons. That's it. Okay. Now in the y direction, got a little bit different case here. We got 35 up and 20 down. So we're going to sum those by taking 35 newtons. And now summing usually means adding, but can't you add negative numbers? So we see this 35 Newton force is being opposed by the 20 Newton force. They're in opposite directions. All right, they're both in the y axis, but they're in opposite directions. One is up and one is down. So you can think of our sum here as adding a negative 20 newtons to it. All right, now as you get used to doing this, you don't write plus a negative. You could just write 35 minus 20, showing that one force is in the opposite direction of the other. And the result of that sum is 15 newtons. I should be careful here. I've got 25 newtons in the x direction, but there's two possible directions along the x-axis. One is to the right, one is to the left. And so I'm going to write to the right. Right as in W-R-I-T-E, to the right, R-I-G-H-T. And this 15 newtons, got to look at the two. Which one's overpowering the other? 35 newtons was up, and we made that upward direction. We made that upward direction positive. And here we're making the right-hand direction positive, just to make a little note of that. You can pick whatever direction you want to be positive. It all works out. So I get 35 newtons minus 20 is 15 newtons. And since that's a positive number, I know that that is up. And I can also look at the forces here. 35 newtons is more up, is the up direction. 20 newtons is down. So in the y direction, these forces are more up than down. And therefore, what I've done here is I've simplified this just a little bit. So I've turned these two forces into one. And we now have a force diagram that looks more like this: 15 newtons up and 25 newtons to the right. All right, so that's how we simplified it. Now we're going to try to simplify it even more. What if we put these two forces together? Can we add these? Can we go 15 plus 25 is 40? Do you see that they're not in the same or the opposite direction? They're not parallel to each other. Instead, they're perpendicular. So the way we're going to add these is think of them in terms of the sides of a triangle. See, if we take the sides of a triangle, 25 newtons to the right, and we add that 15 newtons at the tip of that previous force vector, then we get the two sides of a right triangle. Boop, boop. And the hypotenuse is the sum of all the forces. Notice I'm leaving out an x or a y. This is the sum of all the forces. We've simplified the x and the y directions down into one single amount for each one. And then we're going to paste them on the sides of this right triangle, and we're going to try to figure out how much that side is worth. We add that, we get that together. It's called vector addition. We're adding 25 newtons to the right plus 15 newtons up. And to do that, we need to apply the Pythagorean Theorem, that sum of the forces is going to be the square root of 25 squared plus 15 squared. And that's the step you're going to see in the example in your paper. If you go and calculate it, that'll be 29.2 newtons. Go and try that out now. Make sure you've got all that calculation stuff correct, okay? So 29.2 newtons. There's one little extra feature here. You'll notice on the paper, it does give you a mass. And the mass given, let's see, let's take a look at that paper. I think it's 10. And you'll see right up here, to the upper right hand corner of that 35 newtons on the force diagram, says M equals 10 kilograms. So what's that there for? Well, this object has inertia. And even though there's 29.2 newtons acting on it, if the 29.2 newtons acted on, let's say, a little tiny bug, oh man, that thing would go flying. That thing would accelerate like crazy. But if 29.2 newtons acts on a human being or a car or a boulder, that's going to be kind of an insignificant force compared to a little tiny object like a baseball or a bug. So the inertia comes in with the rest of Newton's second law. So if we just write that out, we'll see what to do with it. Sum of all the forces acting on a body equal the body's mass times its acceleration. That's Newton's second law right there. And what we've already done is we've figured out what the sum of the forces is. It's 29. So I'm going to substitute that in right here. 29.2 equals mass, which is labeled as, you'll see up there, 10 kilograms on the page. So that'll be given to you. The mass is 10 times acceleration. That means if we divide both sides by 10, we're going to come up with our acceleration rate. And 29.2 divided by 10 is really easy. It'll be 2.92. 2.92 what? Meters per second squared. And that's our answer. That's what we're looking for. That means altogether, this object's accelerating at 2.92 meters per second squared. As a little added bonus, if you are interested, if you look at that, the 2.92 is in this direction. And that's from that 29.2 newtons that we figured out. That's what this hypotenuse came out to be. So it is possible also, if you want to figure out a direction. To find the angle, we take the inverse tangent of the opposite side, or the side up here. So this angle theta is the same as the angle theta over here, and the opposite side is 15 divided by the adjacent side. So katoa, tan is opposite over adjacent. So our opposite is 15 divided by 25. And you plug that into your calculator, inverse tangent of 15 over 25. See it on my calculator on me, so we'll just look at that example. And that's what we're finding down here. Inverse tangent of 15 over 25 equals 31 degrees. So it'll turn out to be, that's 31 degrees. So what do we have now? We've got the acceleration and the angle. This net force is angled at 31 degrees above that horizontal. So this is sort of like somebody throwing a ball. You usually don't throw it like straight horizontal. They don't throw it straight up, but it's usually at an angle. And that's how you work these through. Just to sum up, what you're going to be doing on each of these is taking whatever forces are acting on the body. You're going to sum up the x direction. You're going to sum up the y direction. Okay. So the x direction would be this one minus that one. The force in the y direction would be this one minus that one. And once you have those two, you put them together. You got the forces in the x, you got the forces in the y, and you apply that Pythagorean theorem to find the sum of all those forces. And of course, these are all sums here. Don't want to leave out that little detail. So a little sigma means sum. And that sum of all the forces is the square root of that, x1 f of x squared plus f of y squared. Okay. All right. And if your instructor wants you to find the angle, you can go ahead and find the inverse tangent. If your instructor just wants you to find the force, find that force, and finally apply it to Newton's second law. Okay, divide out the mass. That acceleration will be the sum of the forces divided by the mass. And that's it. That's all there is to it. Hope this has been helpful.